Hello everyone. So erythropoesis is the process of formation of RBCs. From the word itself, we get to know erythro means erythrocytes, poiesis means formation. So from the definition, it is the process of formation of RBCs. Now site of erythropoiesis, meaning where is the red blood cells form. It starts in the intrauterine life, that is when the fetus is in the mother's womb. In week 3 of intrauterine life, it starts in the mesoderm of the yolk sac. In month 3 of the intrauterine life, it takes place in the liver. In month 5 again in the intrauterine life, it happens in the fetal bone. Fetal bone produces the RBCs. And once a child is born, it happens in the bone marrow, the red bone marrow. And until you grow up, you become an adult, it happens in the bone marrow, red bone marrow. There are two types of bone marrow, red bone marrow and yellow bone marrow. Yellow bone marrow is mostly associated with fat and adipose, but red bone marrow is a site for formation of red blood cells. Red blood cells, red bone marrow. You can remember it that way. Now, the stages of erythropoiesis, you can remember it with this mnemonic. Priyanka Chopra wears PPE in late rosy evenings. So Priyanka Chopra wears PPE in late rosy evenings. Priyanka Chopra wears PPE in late rosy evenings. Okay, so P stands for pluripotent hematopoietic stem cell. C stands for committed stem cell. P stands for progenitor cell. P for proerythroblast. E for early normoblast. I for intermediate normoblast. L for late normoblast. R for reticulocyte. And E for erythrocyte. Okay, there are total of 9 steps. From progenitor cell to reticulocyte, it takes 5 days, and from reticulocyte to become a fully mature erythrocyte, it takes 2 days. So total of 7 days. So this is a mnemonic. These are the steps. I will be explaining this entire thing in the form of diagrams first, so that it becomes easier for you all. So the first step, P, is pluripotent hematopoietic stem cell. Okay, now pluripotent hematopoietic stem cell. Okay, just assume this is a cell. It does two things: it renews and differentiates. Okay, this cell differentiates to form the committed stem cell, which is step 2. Now let's assume this is a step. There are of two types: myeloid series and lymphoid series. The lymphoid series is not of that importance because it gives rise to the lymphocyte. From the name itself, lymphoid series, lymphocyte. The myeloid series gives rise to the erythroid series. The erythroid series then gives rise to the progenitor cell, which is step 3. Progenitor cell. Okay, progenitor cell are of two types again: burst forming units and colony forming units. Burst forming units, from its name itself, they are a burst of cells. They are large, oval and multilobulated. The factor over here that is responsible is BPA. Okay, in colony forming units, they are smaller and they form colonies, but they are more mature than the burst forming unit cells, and the factor here responsible is erythropoietin. Okay, now progenitor cell, that is burst forming units, form colony forming units from immature to mature. Colony forming units give rise to proerythroblast, which is this step. The proerythroblasts are large cells, 15 to 20, and they are large cells They are irregular in shape. They have a nucleus, a nucleoli, and this is a cytoplasm. Let's just understand this stage now properly. Proerythroblast. Pro means early. So, like, means the first thing, pro. So, it has a nucleus which occupies 80% of the cell. Inside the nucleus, it has a nucleoli which is basophilic in nature because of polyribosomes. Let's assume basophilic for blue color. Okay, the cytoplasm is scanty because majority of the cell is occupied by the nucleus, so it's very scanty, very less, and it is also basophilic. There is RNA present, and therefore there is high protein synthesis. Okay, so large cells, irregular, oval in shape, they divide by mitosis. It has a nucleus which occupies 80% of the cell. It has a basophilic nucleoli, and the cytoplasm is scanty, and it is again basophilic. Then we go to the next step, that is early normoblast. Now the cell becomes smaller in size, that is 10 to 16. Okay, this is the cell. It becomes smaller in size. Over here we see the nucleus. Over there it was 80% of the cell, but now it occupies 70% of the cell. HP starts appearing, meaning hemoglobin starts appearing, and the nucleoli which was present over here, it starts disappearing, and instead chromatin fibers start appearing. Okay, there is condensation of chromatin occurring. This is still basophilic in nature. HP starts appearing, and this is occupying 70% of the cell. In intermediate normoblast, the cell again becomes smaller, 10 to 14. Over here, as you can see, the cytoplasm becomes pinkish, from blue to pinkish, because this HP synthesis keeps on increasing, and that's why it's blue in color. Okay, and the nucleus occupies 50% of the cell. From the beginning 80 to now 70 and now 50, it occupies 50% of the cell, and this chromatin condensation keeps on increasing. This is the stage where mitosis stops. In late normoblast, the cell again keeps on getting smaller. It occupies, and the nucleus, which was occupying 50% of the cell, has now become so small that it has disappeared and is thrown out by extrusion. Okay, the cytoplasm, which was pink here, becomes red here because of high amount of HP synthesis. It becomes acidophilic. Okay, your HP synthesis keeps on increasing, and it is completed by this stage. It is late normoblast. Okay, this is the reticulocyte. Okay, it is basically a flat disc shape, an immature erythrocyte. It is larger than an erythrocyte. Over here, the nucleus which was there is thrown out, but it is still slightly basophilic in nature, and HP synthesis is at its peak over here. Okay, so this is a reticulocyte, which is an immature RBC. It is larger, flat, and it is disc shaped with no nucleus. After 2 days, we have a fully grown mature erythrocyte, which is smaller than a reticulocyte. It has no nucleus. It is eosinophilic, biconcave disc shape like a coin, and it is mature. So these were the stages. We can just revise. Pluripotent, hemopoietic stem cell, committed stem cell, progenitor, proerythroblast, early normoblast, intermediate normoblast, late normoblast, and reticulocyte. Okay, and erythrocyte. So let's revise the steps very quickly. Pluripotent hemopoietic stem cell, they differentiate to form committed stem cell, which are of two series, myeloid series and lymphoid series. The lymphoid series form the lymphocyte. The myeloid series give rise to erythroid series, and these give rise to progenitor cells. The burst forming units, which are immature cells, form the colony forming units, which are mature cells. The colony forming units form the proerythroblasts, which are large irregular cell. The nucleus occupies 80% of the cell, and the nucleoli is here, which is basophilic. The cytoplasm is scanty and is also basophilic. Then we have the early normoblast, which is 10 to 16 mu, and it has a smaller nucleus which occupies 70% of the cell. It is basophilic, and HP starts appearing, hemoglobin starts appearing. The nuclei which was present in proerythroblast starts disappearing, and there is condensation of chromatin. From this becomes this chromatin fiber starts condensing. Over here, since HP synthesis keeps on increasing in intermediate normoblast, the cytoplasm becomes pinkish. The nucleus, which was occupying 70% of the cell, now occupies 50% of the cell. HP concentration keeps on increasing, and even the chromatin fibers keeps on condensing higher. Mitosis stops in intermediate normoblast. In late normoblast, the cytoplasm is completely red, that is acidophilic, because of highest amount of HP synthesis. The nucleus is so small that it is thrown out by extrusion, and HP synthesis is completed by this stage. In reticulocyte, the HP synthesis is at its peak. It is a flat disc shape, no nucleus cell, immature, and slightly basophilic in nature. Once it gets rid of its basophilic nature, it becomes an erythrocyte, which is eosinophilic in nature. It has no nucleus, it is smaller than a reticulocyte, it is biconcave, disc shaped. So these are all the points which I have